Okay, today we're going to learn about the volumes of pyramids and cones. So we want you to learn how to find the volume of a pyramid as well as the volume of a cone. So let's first talk about the volume of a pyramid. The equation for this is volume equals 1/3 base times your height. And this is the area of your base. So the area of whatever shape happens to form that base of the pyramid. That means it is most likely going to be something other than a triangle. It could be a triangle, but whatever it is, it'll be at the bottom of this pyramid, the thing that's sitting on the ground. Okay? So, another thing to note about volume of pyramids is Cavalari's principle we can use. This means we can find the volumes of oblique pyramids as well as right pyramids. We just need the height. Okay? So, the height in this case is the distance from that vertex to the center of the base. This is the height. Okay, and that is something that we need here. Okay, this is not our slant height that we used for surface area. This is the actual height of the pyramid. So, a lot of times we need to solve for this height using Pythagorean theorem, because if you notice, right here we have a right triangle here. Okay, if it is a right pyramid. If it is not a right pyramid, then you may not use the Pythagorean theorem to find that height. You will have to have it given to you somehow in the problem, because we haven't learned the other methods for finding that height with trigonometric values. So let's talk about how to work this out. So we need to determine our height. So my height squared plus 4.8 centimeters squared should equal my slant height of 11.1 centimeters, and all that squared. So once I solve that out and take my square root, I should get that my height equals 9.9 actually should say, 9.90 centimeters squared. Okay, now I need the area of my base. That's going to be my big B. Since this is a polygon, I can use ASN over 2. My apothem is 4.8 centimeters. My side length is 7 centimeters. And I've got 5 sides. Little squiggly line here, all over 2. So 4.8 times 7 times 5, all of that divided by 2. My area of my base is 84 centimeters squared. So my volume is going to be 1/3 times 84 centimeters squared times 9.90 centimeters. That should not have been a squared. So my volume should be 277.2 centimeters cubed for this pyramid. Now let's look at this other example problem. Okay, here again we're given our volume. Now notice in this problem my base is a triangle. Okay, this is my base. So I'm going to have to use 1/2 base times height as my area for my base. And this is my little b and my little h of my triangle, my height of my triangle. So 1/2 base times height of my triangle is going to be 1/2 times 6 feet times 8 feet, which should be 24 feet squared. Okay. Remember, volume is going to equal 1/3 the area of my base times the height of my pyramid. Now this is the height of my pyramid here, not the height of my triangle, the height of my pyramid. So I can fill everything in now. 1/3 times 24 feet squared times 8 feet. And this should end up being 64 feet cubed, cubic feet of volume in this pyramid. Now let's talk about cones. Now cones have the same exact formula, 1/3 base times height, and this is for the same reason that we talked about pyramids and cones and prisms and cylinders all having the same formulas. But my volume is going to be 1/3 my area of my base. My area of my base is a circle, so that's why I have my circle area formula plugged in for this already. So 1/3 times pi times my radius, which is 8 squared, times my height. Now in this case, I don't know my height. Since it's a right cone, I can figure out my height though. So I can use Pythagorean theorem, so h squared plus 8 squared should equal 17.9 squared. So I get h squared equals 256.41, and I take the square root of that to find h is 16.01, and that is kilometers. So I will put in 16.01 kilometers times my 8 squared for my radius divided by 3, and I get 341.61 pi. So I'm going to multiply by pi, and that is 1,073.19 kilometers cubed, because that's cubic units for that. Okay, and if you have nice numbers, yay, keep it in terms of pi. If you don't, you might as well approximate pi out anyways, because it's all just an approximation anyways. So let's talk about volume of oblique cones. Now, we mentioned when we have cones that are right cones, we can solve for the height. When we have volume of oblique cones, you're going to need to be given this height, okay? Because you don't have the trig necessary to determine the height for yourself, okay? So make sure that you are given that height, and it should be pretty easy because they'll be worked exactly as the other ones were for cones. So we've learned how to find the volume of pyramids and cones for both right and oblique pyramids and cones, and that's it for today.